In this video we are going to see about pitch factor. Pitch factor is represented as Kp. Okay, the Kp is the one of the main factor in the EMF equation of AC machine, right? And the Kp value is vary with respect to the coil span variation. The coil span is also called as coil pitch, and based on the coil span based on the coil span we can classify the winding types in three. One is short pitch, another one is full pitch type, third one is over pitch coil. Okay, so the short pitch type is always we are using short pitch type of winding in AC machine, and full pitch type is used in DC machine. So practically short pitch type and full pitch type of winding is available, but over pitch is not available. We have to see the reason of why we are selecting short pitch coil in AC machine and full pitch type of winding in DC machine. We will see. I have taken two pole. Okay, I have taken two pole. The first pole is N, second pole is south. Okay, and I have marked pole pitch here. The pole pitch is nothing but the distance between middle of the two adjacent pole. So here these two are adjacent pole, and the distance between these two midpoint is called as pole pitch. In electrical machine, always pole pitch is 180 degree. Okay, the pole pitch is always 180 degree electrical. So this is about the pole location in all the machine, and we have to see the coil location. To explain the coil location, I am showing this model here. This is 10 slot, okay, 10 slot and 2 pole model. Okay, here 10 slots, so each pole carries 5 slots. Okay, so 1 to 5 these slots for the first pole, and 6th slot to 10th slot for the second pole. Okay, so to explain it clearly, you have to assume I am going to cut here, okay, at nearby the 10th slot, and I am going to put in this way, linear way. Okay, from 1 to 10 it will be the first 5 slot allotted for the first pole. Okay, first pole, and next slot allotted for the second pole. So first pole north and second pole is south. Okay, likewise it will be, and after that here all the slots are numbered, and practically the slot number will be more, but for the easy calculation I have taken only 10 slots. Okay, so I have to take first full pitch concept. To show the full pitch concept, you have to see here. There is a proper way to accommodate the conductor in appropriate slot in full pitch. So in the full pitch, the way is I have taken only one turn conductor. Okay, so this is only one turn, and there are two conductors, conductor 1 and conductor 2. Okay, only one turn is there, right? So I need to place for each conductor in each slot, right? So I have to choose that correct appropriate slot, and the first conductor should be placed the slot which is lying exactly middle of the first pole. Okay, so this is the first pole. In the first pole, exact mid is here. So in that the third slot is lying here in that middle. So that is the slot which is lying exactly middle of the first pole is suitable to carry the first conductor. So I am placing this conductor here. Okay, So I am placing conductor here. Okay, and after that, second conductor of the same coil should be locate in the another slot, uh, which should be lie exactly in the middle of the adjacent pole. Okay, so adjacent pole is south, and here 6 to 10 is there. Exact middle is 8. So I have to place the second conductor in the 8th slot. Okay, so I have, like this way I have to select. Okay, I have to fix here, and the terminal end of the coil should be shorted together. So this closed loop will make turn. Okay, this closed loop will make turn, and there will be a two conductors. Okay, there will be a two conductor. It will be make one turn. Okay, so this is the way to place the conductor. And if you are seeing the displacement between the two conductor, you can see it is lying exactly middle of the two poles. So we can say in coil span, in the full pitch concept. Okay, in the full pitch, the coil span is equal to full pitch, because it is also 180 degree. Both the conductor are displaced 180 degree. Okay, now there will be a EMF in each conductor. In case if it is generator, the EMF going to occur across each conductor. So we have to find that. First of all, the first conductor terminal is 1 and 1 dash, and second conductor terminal is 2 and 2 dash. Okay, so in the first conductor, the voltage across the first conductor I have taken E, and their polarity is plus and minus. And then second conductor EMF also I have taken capital E, and then the polarity is reversed. Okay, compared to this one, this is reversed, because we know obviously the EMF occur across the conductor which is belonging to south pole always opposing nature. Okay, because both the opposing nature of the EMF occurring across the conductor under the north pole, because both are opposite polarity. That is why here the polarity will be reversed compared to this. And the EMF, okay, so the total voltage is V12, that is resultant voltage. To find the resultant voltage, I have to write KVL equation. So for that, KVL V12 equal to V11 dash plus 2 dash 2. Okay, so that's why I have written here. And V11 dash is E equal to E of 0 degree, and V22 dash is E 180 degree, because it is 180 degree. After 180 degree displacement, we have second conductor. Okay, but we know the voltage value V22 dash, so I have to rewrite this equation as V12 equal to V11 plus within bracket minus V22 dash. And to get the resultant value, I need to find the phasor vector diagram, but we can't simply add this, because it is magnitude and angle dependent. Okay, vector quantities. That is why we have to see the vector diagram. In the vector diagram, the first quantity is V11 dash. So V11 dash is E0, and so it is, I am taking this is reference. So it will be reference in positive x-axis. And the second quantity is V22 dash. It is 180 degree. E magnitude is E and 180 degree. So from the 0, after 180 degree displacement, I am getting this vector line. Okay, now I need to add, but this should be minus V22 dash, right? So to get minus value, I have to assume this line in right side direction. Okay, so I will get V11 plus, after shifting this line to this side, I will get one more line. So both the magnitude will add together. So the resultant voltage is 2E. So the EMF induced induced in the winding, induced in the emission in full pitch condition is 2E. So next we will see short pitch. In short pitch, again have taken two pole and the coil is there. Okay, instead of placing the second conductor exactly at 180 degree, I have placed before this. So the coil span is 180 minus alpha. Okay, the alpha is nothing but short pitch angle. Okay, and V11 dash equal to E0 and V22 dash equal to E angle of 180 minus alpha. Okay, and the resultant voltage, to get the resultant voltage we have to draw the vector diagram. In the vector diagram, the first parameter V11 dash is here, and V22 dash is 180 minus alpha. This is 180 line, so 180 minus alpha means this is the 180 minus alpha line, and to get the resultant we need minus that voltage, so minus of that voltage. So you have to take this line in this on their opposite side. So the dotted line shows minus V22 dash. So resultant of these two lines will give that resultant. The resultant, you have to apply the parallelogram. Now you will get this triangle. In this triangle, that angle is alpha by 2. So after solving this, you will get 2E cos alpha by 2. This is the EMF induced in short pitch. Okay, and then you have to find the pitch factor also. In the pitch factor, the formula is voltage induced in the short pitch winding divided by EMF induced in the full pitch winding. So after solving this, you will get cos alpha by 2. This is nothing but fundamental. Okay, but you have to assume if there are harmonics, several harmonics, if third order harmonics are there in the machine, then at the time our pitch factor will become Kp equal to cos alpha, which is multiplied with the third order number and divide by 2. Okay, for in case of fifth order harmonics, Kp will become cos alpha 5 divided by 2. So in general you can write Kpn, okay, Kpn equal to cos n alpha by 2. Okay, alpha is multiplied with the n. The meaning is the pitch factor at any number of harmonics. Okay, any number of order of harmonics. So this is the pitch factor formula, and we will come in the conclusion. In the conclusion, full pitch voltage is 2E, and for the short pitch voltage is 2E cos alpha by 2. It seems in short pitch winding the total voltage going to reduced by this factor, cos alpha by 2 factor. Okay, so this is the main disadvantage of short pitch, and after that the advantage also there in the short pitch, that is by using that factor, okay, the winding pitch factor, we can reduce some number of harmonics. Okay, so that is main advantage in the short pitch concept. That is why we are using full pitch concept in DC machine winding, and short pitch concept in the winding which is accommodated, winding which is there in the AC machine. Okay, because AC machine, AC means that will be a harmonics. To eliminate that harmonics, we need to approach this concept, right? And along with that, we have to see over pitch also. In that over pitch, see the diagram. Here first conductor is here, and second conductor I have drawn in black color line. No? Instead of lying 180 degree, it is getting after with some angle it has been placed. That angle is nothing but alpha. Okay, alpha. So the total coil span in the over pitch is 180 plus alpha. Now see the pitch factor. So the voltage across the first conductor is same, V1 0 degree, sorry, E and 0 degree, and V22 dash is EMF E and angle is 180 plus alpha. So we have to find the resultant voltage. You will get 2E cos alpha by 2, and the pitch factor also you will get. Here also the same advantage and disadvantage. So we can conclude one thing. This is also suitable for AC machine to eliminate the harmonics, but we are not using over pitch concept in the AC machine. The reason is, in short pitch the conductor length is less, even though to get the same voltage. Okay, but in the over pitch, to get the same voltage, whatever we are getting in the short pitch, the same voltage going to occur across the over pitch coil terminal also, but we need lengthy wire to so that is why this is the main drawback. That is why practically we are not using over pitch concept in the AC machine. Instead of over pitch, we are using short pitch only. Okay, so I think you understood this, and thank you for watching this video.